Hello, in this Excel tutorial video for Chem 1B, we'll be looking at the next part of the data workup for Experiment 7. If you recall, last time we had done some standardization titrations and done those calculations. If you did those by hand, you're going to be able to enter them in manually here, or we'll refer back to that sheet. I'm on a second tab. I have my volume of base added and my pH. Looks like the student recorded the target volume of base added, the volume of titrant, rather than reading it off to 2 decimal places, but I've adjusted the decimal places using the increase-decrease decimal, so it's displaying the proper number of significant figures anyway. I'm going to add some space at the top of the spreadsheet, drag over it, right-click, insert rows, and I'm going to type in my name, and then my class information. I'm going to have some space over here for constants we're going to need in the calculation. We're going to need the concentration of the acid that we're using. This is what we put in the Erlenmeyer before we started our titration. The volume of acid that we used, the concentration of base, and we're going to need the Kw value to convert excess hydroxide to hydrogen ion. The concentration of acid, either you can type the concentration in manually here, or you can refer to it on the other sheet. I'm going to hit equals, click on the standardizations tab. Here's my standardization for hydrochloric acid, and there's the average concentration. Click on that cell and then hit the enter key, and it will pop you back. Okay. My concentration of base, I enter much in the same way. The volume of acid you should have recorded when you did your lab. In this case, it was 34.80. That didn't display with the right number of decimal places, so increase, decrease decimal. And when you're entering exponents in Excel, you enter them as 1 and then E, in this case dash 14 for my KW. Okay. The other rows or columns I'm going to calculate, and this is basically the thing I'm trying to get is a pH calculated. Let's change this label to pH measured. And I could either enter a big nasty equation in this cell, or I can have some other columns that help me calculate it and see what I'm doing. And I'm going to prefer that. I'm going to have a column for my hydrogen ion concentration, my millimoles of HCl, my millimoles of NaOH, my millimoles of titrant, and my total volume. And these are the bits that I'm going to use to help me through this calculation so it visually makes sense what's going on. The total volume is relatively straightforward. It's the volume of base that I've added plus the volume of acid that I started with. And I'm clicking on that volume of acid. I'm going to hit F4 to toggle in these dollar signs up here, and I need that because I want that cell to stay put as I copy it down. The millimoles of titrant is going to equal the volume of titrant that I've added times the concentration of titrant, in this case the concentration of the sodium hydroxide base. That needs to be an absolute cell reference again. The amount of sodium hydroxide that I initially have is going to be relatively negligible. All that sodium hydroxide I'm adding is going to neutralize. So I'm going to start in the initial phase of the titration calculating the amount of HCl that remains in solution. And that's going to be equal to the amount I added at the beginning, which is the concentration times the volume. That gives me millimoles. Both of those should be absolute cell references. And then I'm going to subtract whatever sodium hydroxide I've added that's neutralized some of that acid. And that's the millimoles of titrant added. Okay. To get to the hydrogen ion concentration, I need to get that millimoles to a concentration. And I need to recognize that hydrochloric acid is a monoprotic strong acid, so my concentration of hydrogen ion is going to be equal to the concentration of HCl, which is the millimoles of HCl divided by the total solution volume. Okay. And none of those are absolute cell references. They're all in the same row. I'm going to copy them down. The pH is equal to the minus logarithm, and you can just enter the minus and then type in the function log of the hydrogen ion concentration. Okay? And that's a reasonable value. If you start getting values that don't make any chemical sense, you look for mistakes that you made in the calculations. I'm going to take that whole mess that I just typed in. I'm leaving the sodium hydroxide blank because I don't have excess sodium hydroxide at this point. And I'm going to go ahead and copy it down the sheet. And I'm going to copy it down quite a ways, say just to the end. And I want you to notice that it got a little fishy here. I'm getting an error. And the reason I'm getting an error here is I can't calculate a logarithm of a negative number. That doesn't apply. And I'm getting a negative number for the amount of moles of HCl, and that doesn't make any chemical sense. Okay. I'm going to go ahead and delete those. The total volume calculation still works and this still works, but what happened here is that I now have excess hydroxide, not excess acid. And so I'm going to calculate this cell here. This was my millimoles of sodium hydroxide is equal to the millimoles of hydroxide that I've added minus the concentration of acid times the volume of acid. In other words, the amount of hydroxide I added minus what was consumed by the acid. Okay, and that gives me sodium hydroxide. I can calculate my hydrogen ion concentration, this was this rho E, as equal to, now the sodium hydroxide is a strong base, dissociates completely and gives me one hydroxide for each sodium hydroxide. So I can take this, I can calculate for starters the concentration of hydroxide is that millimoles divided by my total volume. Now that's hydroxide, not hydrogen ion. And the way I convert hydroxide to hydrogen ion is Kw divided by the hydroxide. And that Kw value is up here. That needs to be an absolute cell reference, and then divided by that hydroxide ion I calculated. And now things are looking closer to the way they should. Drag it down the rest of the way. In some cases, you'll get a pH reading very close to your equivalence point, and this one's reasonably close, but it's still calculating that 8.45 okay. If you get a value close to your equivalence point, you can just enter a calculated value of 7 and be done with it. But in here, 4.5, that's a fine calculation. 10, I've skipped past the equivalence point. Okay, last step is to plot our data here. And I'm going to put the cursor there, hold down the Shift key, cursor a little to the right, and hold down Control, and it will pop all the way down to my block of data. Click on the Chart Wizard, XY Scatter. Don't use smooth curves. I'm going to click this one for now. And that looks like the right data range. My title is going to be Strong Acid Titration. My x-axis was the volume of titrant in units of milliliters, and my y-axis was my pH. Okay. I'm going to turn off the legend. I'm going to turn off grid lines, and then I'm going to enter this as a new sheet. Strong acid, strong base, plot. I'm going to get rid of this gray. I selected it and hit delete. And I want to change this blue line. This was my data. I want to change this to be data points. So I want to have automatic markers and no line. And now those are my data points, and the pink line is my calculated fit of that titration curve. And that concludes the video on how to calculate a simulated titration curve for the titration of a strong acid with a strong base.